In this video, we will discuss the basic concepts of Secure Socket Layer (SSL), a Transport Layer Security (TLS). The objective of this video is to explore the SSL features and go through the handshake process and see it in Wireshark in live demonstration. SSL TLS features. SSL TLS is a networking protocol which ensures security of connection between web client and web servers over an insecure network. It is a, it, it works in transport layer protocols which uses public and private keys to provide flexible encryption scheme. This set of protocol uses X509 certificate and asymmetric cryptography to authenticate counterparts with whom they are communicating, and thus further make use of symmetric cryptography for channel encryption. The whole purpose of this process is to prevent communication from sniffing and tampering. Overall, TLS and SSL protocol ensures confidentiality, message integrity, and authentication of keys. However, it can't ensure security service like non-repudiation and neither proof of origin nor proof of delivery. Perhaps the best feature of TLS or SSL protocol is that it is independent of application layer, which means any application can be protected. Uh, the next slide, we'll discuss here the handshake process. On the left side is the client and the server is on the right. At first, the client will send a hello message to the server. Before going to the detail, let's see Wireshark first. So I have already started the Wireshark here, and I have logged in to ECU portal. So how do I know that ECU portal using SSL security features? You see the log button here, just click it. It says the connection is secure. It also provides a third-party certificate, which means they're using a secure socket layer. Going back to slide. Now, the whole purpose of this handshake process is to make sure that this is the right client, this is the right server, and whatever the information they are exchanging is secured. Nobody is tampering or sniffing in the middle. So the first step is that client will send a hello message to the server, and this sort of exchange between client and server will go back and forth. So look, client sends a hello message to server and server returns a hello message to client. They exchange similar kind of information. Both generates a random number. Client sends a list of cipher suites out of which server will agree with one cipher suite with which they will continue to communicate further. They share the compression method and protocol version. So let's see it in Wireshark directly, how it works. So initially, so their frame, Ethernet, this is the MAC address of the client, this is the address of the server, this is the client IP address 192.168.1.156, which is here. So this is the source, which means client is sending destination to server. It is using transmission control protocol. Source port and destination port is here. What we are interested in SSL, secure socket layers. Now, if we go to detail, it's saying handshake protocol is client hello, and in handshake protocol, they're going, as I said, they generated a random number of 32 bytes here. They have client is providing 17 suites of 17 cipher suites, which means the server has to agree with one of these 17 cipher suits. So let's see, as I said, whatever, I mean, they share similar kind of exchanges. So here, client generated a random number here of 32 bytes. Server also generates a random number here of 32 bytes. Client provided 17 ciphersuits, out of which the server has to choose one. Let's see which one server chose. The server chose these ciphersuits, which is TLS, ECDHE, and RSA encryption SHA-256. So let's see, where is it? TLS, ECDHE, okay, SHA-256. This one. So out of the 17 suits, the server selected this ciphersuit to communicate in encrypted cryptography. Now the compression method, the compression method null, the server hello, the compression method is also same. Okay, and along with this ciphersuits, compression method, random number, they also exchange some other information which is not